Hi everyone. So, if we have watched video 1, and we've watched video 2, and we've watched video 3, then we are ready to actually do coding challenge number 3 in C++. If you haven't checked out these videos yet for lesson 1, lesson 2, and lesson 3, there are some key ideas there that are going to totally go over your head if you haven't seen them. So please go back and watch those videos. There's links in the description and you can find them in the playlist. Please watch those first and then let's do the challenge. Okay, so let's take a look at what we have one more time. And I've explained this in class before, but let's go through it again. First of all, you have cubes placed on the outer zone here, and cubes can be placed in any of these sections, any of these quadrants. They will not be placed in the middle where the robot kind of the main track is, but they could be placed anywhere in these sections. Starting with 3 cubes, the robot always starts in the middle and must be able to intake each cube and deposit those cubes in the end zone. The end zone is anywhere in this area and can basically even, I'm willing to even consider like up to this part here as counting as well. So the main idea is that you could just assume that these are the positions of all the cubes, and you could intake each one by using hard-coded rules. But if you want to be able to accommodate for the fact that maybe there's more cubes, maybe someone decides that there's also a cube here, and someone decides that there's also a cube here, or up here, for example. How do you design your code so it can actually intake any number of cubes you like? Well, let's think about this for a sec. Basically, you need to use sensors to detect where the cubes are, and those sensors are already attached to the robot. You have 2 motors on the left and right, and then you have 3 ultrasonic sensors as well as a gyro. So if we take all of that combined, we can actually get pretty precise information about the environment we're in, and we can quite accurately intake cubes. I've seen some students be able to successfully complete the challenge only using one of the 2 ultrasonics. You could think of one of them as a redundant ultrasonic. You don't absolutely need to use it, but you can if you want. So you could just use the center one, and you could probably be successful with that, or you can try to compare the data from 2. Now, what else do we need to do here? I think that's it. The top ultrasonic, of course, is for detecting the ceiling, the roof part here. So you can use that to make sure to know when you have moved far enough to stop pushing forward and to then be able to back up. This could be replaced with a bumper switch if you like, but I find that the bumper switches in Robot Mesh Studio are really funky, so it's better to probably use an ultrasonic. And that's why I did that. All right, now, if we're going to start coding, what should we actually be doing first? I would say that the first thing to do is to start by building up some functions, some foundation things, behaviors that we want the robot to be able to do. Well, we want the robot to be able to move forward, so we definitely need that. We also want the robot to be able to turn to a certain amount of degrees so that we can realign to whatever position we want. We want to be able to say, okay, hey robot, turn to 90 degrees. Oh, hey robot, turn to 180 degrees. That would be really handy. So why don't we start by building those 2 functions? Okay, and so what we're gonna actually ignore the main completely. We're gonna not even go in there. We're gonna start by right away diving into creating functions. And so the first function we should make is maybe the turning function. So we type in void, which means that it's not going to return anything. Then we say turn 2, and then that's going to be a certain number of degrees. So we pass in, we could do float if we wanted to be really precise, or we could do integer if we wanted to be less precise. Let's do integer just to be, because we don't need like 92.5 or whatever. We'll just be full whole numbers. Degrees, so we'll go num degrees, and then we have some brackets here, and inside this we're going to have our we're going to start doing some code. So this is where we're going to actually need to do, what we could do is we could say, okay, well, let right motor dot spin, and then we pass in the vex direction type forward, and then we have left motor dot spin vex direction type reverse. That'll give us a turn. But, and always test your code as you go, because if you make a mistake later, you're not going to know what the mistake was a result of. So we have our 2 motors spinning. We need to provide some amount of sleep. So we go vex sleep milliseconds. Let's do 2000 for now. So it's just going to sleep for 2 seconds, and then we're going to have stop and left motor dot stop. So we just have the turn set up, and then we're going to go turn 2, and then we pass in a number of degrees. It won't actually use that number of degrees yet. We'll just say 90, and let's see what happens. So we'll test to make sure that it actually does something. There. So it actually turns. We know that our code works. Now let's take a look at the gyro and how we can utilize that, as well as how we can actually make this work by taking the parameter. So how do we use the gyro? Okay, so I added one thing here, which is to make it sleep until it touches the ground, because the robot is slightly above the ground at the beginning. So that'll actually help it spin a little bit more consistently. But now that we're ready to use the gyro, what do we actually do? Well, the gyro's name is called mygyro, and in order to get a value from it, we just go, because it's the old v4 gyro, we go mygyro.value, and we pass in the rotation units that we want, which is degrees. And that gives us a value. What we could do is we could say, and it's going to pass it out to us as a, it returns an integer that represents the unit value. So then what we could do is store that in a variable. So int, we could say heading equals mygyro.value. And that is going to store the value, but it's not actually going to do anything yet. So we press play. It's still going to do its thing. We have to actually utilize this variable. You can even see it's highlighted saying we're not actually using it. What we need to do is we need to actually have it be checking the heading as it's turning. And the only way to do that is to actually have it be in a loop. So what we could do is we have to think about, well, what kind of loop should we use? Should we use a for loop or a while loop? In this case, we don't know exactly how many times to repeat, because this degrees might change. So you could instead use a while loop. So what we do is we put everything into a while loop, And we're going to be careful. We're going to use while true, which means it could potentially cause an infinite loop, but we're going to try it anyways. And all of this code is going to go inside of the loop. And the stop code is going to go outside the loop. So now we have the heading, and we're going to actually define it at the top as well. Int heading equals 0, and then we go heading equals my gyro.value. So we've declared it once, and then we're going to keep using the same variable. Then we start spinning. And we could actually technically have the spinning also be outside. So we start spinning outside of the loop, so that the motors aren't continuing to get commands. They only get the command once. The only thing we need to know is when to stop. So in this case, we have the value. We have heading equals my gyro.value, and why don't we actually print out that heading as well? So what we can do is go brain.screen.print, and we choose heading, and we go brain.screen.clearscreen. So it's going to just print it in the same spot. In order to do that, we also need brain.screen.setCursor11, and we need to have a sleep in between the time that it's printed and the time that it's cleared. And we're going to have this be 100 milliseconds, so then it shows up. Now, we don't have a condition that's going to actually end this loop. And also, this is going to be output to the brain for reference. We actually have to use the heading. So what we should do... So yeah, we don't have anything to break out of this loop yet. We have everything else, but it's just going to keep going forever. So the only other thing that we need to do is we need to have a condition. So after we print, what we're going to do is we're going to have an if heading is greater than or equal to, and then we take this num degrees, then we use the break keyword to get out of the loop. And that will give us our loop. So let's run it, and hopefully it'll actually work, and it'll output the degrees as well. Let's see. Oh, there we go. Hey, that kind of worked. It wasn't as precise as I was hoping, but it worked. We could also move the clear screen to the top so that it ends with a value printed, so we actually roughly have an idea of what the values are. So it stops at 102 instead. Now that's because we also don't have correct stopping set up. So why don't we try to do that as well? Because right now we passed in 90, it stopped at 102, so we don't like that. What we're going to need to do is create another function called stop. And that function is going to take your right motor and left motor stop, pass those in, and then we're going to go, we're going to pass in the stopping type, break type, and we're going to choose, we'll choose break for now. We could choose hold, but I don't know if they actually make a difference on Robot Mesh. So let's see how much that helps, and then we also pass in that function inside the other function. So stop there. So now we've built two functions and we're using them together. We run this again. And the other thing that we could do to be even more precise, so it helped us a little bit, we can also change the velocity of our turn. We can pass in a speed in here, so go double speed, and then we're going to go right motor dot set velocity, and we go speed, and then vex velocity units %, and then we're going to copy this, and we're going to put it here, left motor, set velocity. And then we have to pass in the speed in our turn function. Let's change it, let's decrease it to 20% of its total. So that'll be really precise, I hope. Oh, still not. Let's stop. Oh, because turns are actually crazy fast. Let's go 5. Let's try that. There we go. Aha! Look, hit right at 90. Although it does look kind of like it's not quite at 90, but it's pretty darn close. So that is how we've tweaked things. We've built a stop function, we've built a turn to function, and we've used a while loop to get that going. So that is a very basic introduction to how we can do the how we can use the gyro. And in the next video, I'm going to chunk this up a bit. In the next video, we'll talk about how to use the ultrasonic sensor to detect one of the cubes. Right? Thanks for watching.